All right, we should be good to go.
All right, next thing on the list is introductions and new faces. I don't see anybody here who hasn't been here before. So we'll move along to release planning and updates.
For PAC, we are trying to get an RC out this week. There's a bit of a package restructuring happening for the library. We were informed of a bug where right now the client isn't really usable for some of the options, or and so we're trying to get that addressed before we do this release. So some point this week, we're hoping to have that RC.
Awesome. Any other release planning updates from our sub-teams?
Yeah, for distribution for GitHub Actions, there must have been a change in the GitHub API that we use to automatically approve new namespaces. So it was failing every time for a couple months, and just released a new version with a majorly updated Go GitHub library. So just FYI.
The implementation team is actively working on the SBOM track of work. Should be the majority of the next platform and build pack API. So we hope to have a new minor release in the next week or two.
Awesome. Be excited to get that stuff out. Unless there are any other release planning updates, we can move along to lifecycle artifact distribution, or spec, I guess. Spec a topic.
Yeah, I guess just spec review from yesterday. I kind of grouped them in to hopefully time box them into one slot versus each having their own thing.
So yeah, I could start talking about the first one, the lifecycle artifact distribution. So if you click on that link there, Jamil is working on some changes to basically define how a lifecycle is distributed. And I think in our initial take, it was about the OCI image itself, something that we already produce, but never really quite spec'd out or documented. But a lot of platforms are kind of relying on it. And so we're trying to put that into the distribution spec with the end goal of defining what an overall builder looks like, right? So a builder has the build packs at a certain place and locations with certain labels, and then the life cycle in a certain place with some of the other labels. And so our idea is to kind of create this composition of all these components that are defined of how they're distributed. So build packs, life cycle, and build image, and then say, okay, you put all these together, and then that's called a builder, right? Or something like that. And it might have some additional data. So we kind of got into that and we started working through some of this. I think the latest thing that came up was about the lifecycle descriptor and how that opened up a conversation around how we distribute the lifecycle outside of images, right? And whether that's something that we also want to spec out, right? Because again, there are, I guess Pack, for instance, does consume the lifecycle as a tar. And so then it expects the lifecycle descriptor there and so forth. So I think that was Natalie's point. As I kind of slept on that for a little bit, I did want to kind of bring up or talk about other aspects of it. The primary sort of like suggestion that I have is It depends on, this is all going to be in a distribution spec. This distribution spec is going to be versioned, right? And if we're distributing the life cycle in a tar, how do we determine that distribution version, right? And what I'd like to have is something that's consistent across all the different components, right? So that you know exactly where to find this sort of information for the life cycle and where you could find it for the build pack or build packages. And so one of my initial thoughts was, okay, so build packs are distributed in build packages, which in a tar format would be OCI layouts, right? And that kind of opens up my question of, would we be opposed to releasing the life cycle as an OCI layout tar and defining it that way, and then pack could consume it that way and so forth, right? That could be part of the distribution as opposed to just individual tars for different architectures and stuff like that.
I like that better. Oh, sorry, Natalie.
Oh, no. Well, so my initial thought is, oh, that's more work for what benefit, right? I guess if what prompted this question is, I want to do pack create builder with my homegrown life cycle, right? What if we had pack the ability to consume a life cycle from an image, right? Just the same way if you're providing, a build, like here's the URI for my build pack, it could be in a registry. If pack could accept, the URI to the life cycle in the same way, then you don't even have to worry about the tarball, right? That's just like some like pack specific oddity that we don't care, right? From the purpose of enabling others to bring their own life cycle.
Yes, but I guess, are you saying that you're kind of stepping back from the idea of a tar format of the lifecycle being spec'd out?
Yeah, because like the tar, to my knowledge, the only like consumer of that tar is pack when creating a builder. And we've had other requests for, I want to be able to just give you a lifecycle image. Why do I have to go get this tar from GitHub and, like just cut out that step?
Yeah, so my idea came more from the request of speccing out the tar. I think I was on the side of just doing the OCI image. But it does kind of put us at a strange predicament, maybe, of this lifecycle descriptor, right? That still then wouldn't be defined anywhere in the spec.
So the descriptor is actually, so whatever ends up in the lifecycle TOML, in a lifecycle image, that is on a label. So it's already taken care of.
So I guess the question for me then, right, is, I'm going to play devil's advocate, right? If I have my homegrown life cycle, right, now I need to package it and I want to use pack to do it. I have to reverse engineer how the life cycle repo is packaging the life cycle that pack is then able to consume.
You need a
We
pack
get a target for that. There's a make target. You can just, if you fork the life cycle, oh.
Exactly,
Yeah.
right? Like, I think I've said this point earlier that it's more work, right? If you want to use a developer version of the lifecycle and not which should be the use case. It's more work to make it an image and host it somewhere and use it. It's not a big deal, right? As far as like work is concerned, it's just, if we're talking about the use case, it doesn't help. It doesn't give us much, is what I think we said in a different conversation. Sorry.
Yeah, I think there's like arguments to be made for and against both sides. There's no clear winner. I mean, I'm not opposed to the, like a .cnb file for the lifecycle. It's just, it's more work. It will make our pipelines like, you know, whatever. We have to figure out how to do that in the context of GitHub Actions. So it's like, I'm lazy. That's the only really reaction that I have against the.
So your opposition is not wanting to do the work.
Yeah, because the thing is, because Pack, we got asks for that, you know, can I give my life cycle as a you know, a URI to an image, like for other reasons, right? So it's like, it would make some people happy, and it would just, you know, like, we don't know really who's bringing their own life cycle, you know? And so like, when that person emerges from the theoretical, you know, then we can help them with, you know, okay, I don't want to have to make an image. I want to be able to provide a tar. Like that seems like just a problem that doesn't exist yet.
I mean, I guess to me, like, I look back and think like we're a spec project at the core. At least that's what the CNCF says we are. And this seems a lot more important to spec out how we distribute components so that you could piece them together from wherever they may come, right? Because again, we may not know, but like GitLab, Microsoft, whoever, right? Like they might actually be trying to do their own lifecycle, which actually I think I heard maybe Red Hat at some point was trying to do their own thing. But anyway, like that's the thing, right? Like I get it from a tooling and implementation perspective, it might be a higher level of effort, but I do wonder what our primary objective should be. And if that's the spec, right? Like, because I feel like a lot of things like the lifecycle descriptor and stuff like that, we had an RFC for it, but then Terrence went to go look for it and it's not defined anywhere in the spec, right? And so it doesn't necessarily give us the sense that we're pushing all the way through with some of the intentions.
I don't think it's like incongruous with the spec or something. If we still want to continue to distribute lifecycle binaries and even have the pack CLI, you know, add lifecycle binaries from a tarball and disk to things, like you could view it as we're distributing them so you can follow the spec and create a lifecycle image that looks like it says in the spec, right? So I don't see like a conflict there in dropping and saying the way you're supposed to distribute a life cycle for, you know, consumption by platforms is an image, but then providing both, right? One is a way to help you build the, you know, thing, and the other is the other artifact. I think there are some details like, I don't think we've used OCI artifacts up until now to distribute things. We've used like images that look like container images that are marked with file system layers. So I wonder if like distributing a couple binaries that, you know, like we should think about what the format should look like. But the other thing is I don't think we should use .cnb as an extension because we're using that for build packs. And so I think the expectation there is that it looks like a build pack does, unless we want to kind of think about that differently. But so far, I think that's how we've talked about the file extension.
Yeah, I think for simplicity's sake on the distribution spec, the way I would see it is that anything that could be distributed as an OCI image should also be able to be distributed as an OCI layout tar, right? And if we keep it that simple, it makes it really easy to digest. And there's already tooling that helps you create these sort of packages. So we don't have to, you know, do our own homegrown thing, right? So Natalie, to your point about implementing this, right? It would be using, what is it, like Crane or something? I forget which one of the GCR tools it is that basically lets us create OCI layouts.
I wasn't suggesting that we don't allow OCI layouts, just that we reserve the file extension for build packs so that people don't try to take life cycles on disk and use them as build packs. We could do like CNBL or something if we really wanted to create a file extension for life cycle.
You could just call it .tar.
Yeah, I'm a huge proponent for .tar. I really don't see the benefit of the file extensions, but that seems like, again, bike shedding.
Yeah, I don't care at all. It was in the spec before CNB. I don't think we should use it for other things, at least. If we want to stop using it entirely, that sounds good to me.
I'm good with, I mean, yeah, we can do the OCI layout, distribution for the life cycle. But I think by the same logic, I also want PAC to accept both formats, because I think that would, like, then it's translatable across the board.
When you say both format, which specifically you're referring to?
In my builder toml, when I give a URI, it should be either the path to an OCI layout tar containing the lifecycle or an image.
I agree with you. And I think that's what I want to get at too, right? Like I want to have a distribution that says these are the two types that we have for every component, and then support that across the ecosystem, right? And that makes it easier for other people that develop tools as well when they're trying to consume life cycles and all this stuff. Again, it's a very defined or definitive format.
So when we're saying PAC accepts a lifecycle as an image, the image is a scratch file with lifecycle layers, or is it a container image? You know, let's say Alpine is the base image with lifecycle inside of it.
I would say it would be the former, right? It's Scratch with the locations and the config. It's not really intended to be executable.
So it's not like OCI artifact
It's
style.
not the runtime bundle, not that one. I mean, because if I create an image according to the format, to the OCI format, then I have, the index manifest and whatever, but I can run that. I have to create the runtime bundle to run actually that thing. So what will be PAC accepting that one? I mean, because I can have the OCI image, right? Then I create the bundle, which then I can put into a tar and then put that into a registry, and it's going to work in theory, right? So it's a container image that I can run. So which one are we expecting for PAC to handle? The one that I can execute, or the other one, the actual OCI image?
So Stephen, you brought up the term OCI artifact, right? Could you elaborate on that a little bit, just for clarity on everybody's part?
Yeah, so I think maybe what people are kind of imagining here is something like how a build pack is distributed right now, which is like in the build package format, like a container image that has metadata on it that looks like it's a runnable container image. I don't think we changed the media type unless I missed something. And the file system layers for where the build packs would live, but without any of the bottom layers. If you tried to run it, it would be garbage. You wouldn't be able to start it. OCI Artifacts is a little different. It's instead of using the, this is like what Cosine is doing for signatures and SBOM. Instead of using the media type for the blobs that's like file system layer, you use the media type like for a Cyclone DX SBOM, it's application/Cyclone DX, right? Yeah. And so then a Docker daemon won't try to run it, but also you then wouldn't usually upload the thing as a tarball, with a file system path containing the artifact. You'd upload the artifact directly, usually uncompressed. So at least that's what they're doing for the signature and SBOM. And so it's a little easier to get the binaries directly from the registry. The registry just becomes a blob store with a Merkle tree on top. And so sometimes that's helpful. In our case, I wonder if it's less helpful though, because like the reason we didn't do build packs like this is so we could just manipulate the references to the tarballs and then end up with a new image that's ready to go. I just think it should be a conscious decision one way or the other. I think the main thing I like about the proposal, I meant to say earlier, is it means that you can get all the bits that PAC is going to use to do a build from the same host. You don't have to go out to GitHub to get a lifecycle and then, somewhere else, to get build packs and whatever. It's really makes it easy regardless of what workflow you're using to pull everything from Docker Hub. So as long as that's true, I don't have a strong opinion about it. But because OCI artifacts is a common thing, I think it'd be good to or is becoming more common now. It'd be good to decide if that's something that we care about, or if we want to keep doing the same thing we were doing before.
Yeah, so I like the idea of OCI artifacts long term, but my understanding right now is that their support isn't, I guess, everywhere quite yet, and that's one of the major drawbacks.
I think it's that was true like a year or two ago, but I haven't found a registry that doesn't do it.
Well-
Cosign is very well supported on Docker registries and uses OCI artifacts pretty extensively.
I think even Cosign has a, like, that's not by default that it uses artifacts. I think you have to enable it for this particular reason. And I remember that was one of their biggest pain points, is trying to push registries to allow for artifacts.
I thought it was all artifacts by default now. I know there's been a progression there, but I thought it was all.
I think yesterday Sam brought it up, like when we talked about artifacts. Sam might have more insight here.
Okay. Again, I don't have a strong opinion about which we use, but I haven't heard any issues recently.
Can I raise a quick point about the image? Just to go back to what you were saying about, there's like, Anthony asked the question, is this going to be based on a Scratch image, right? From Pac's perspective, I want to create a builder. It doesn't care what's the base, right? I mean, it could be a Scratch image, but like as an implementation contributor, right, I'm thinking, okay, well, we ship the lifecycle image. It's actually intended to be run, during analyze, restore, and export for the untrusted flow, which I don't think any of that is spec'd, right? As far as I'm aware, in the RFCs, but so I was just hoping that we could make it a little bit optional, whether, from a distribution perspective, you may choose to put your lifecycle, on top of a base image that's runnable, or you may choose for it to be a Scratch image, like who cares, right? But unless we want to go like full, whole hog and spec the lifecycle image for the untrusted workflow.
I think we do care though, right? Because I guess the way I'm envisioning it is everything's layered on top of each other. And so there would be a build image, and then you would throw the lifecycle set of layers on top of it. And they could theoretically, if you have OS layers in there, they would essentially be overriding the build OS layers. So the way I would envision it is it should only encompass the lifecycle binaries. And
can you say that you can just strip out the base image, whatever it is, right?
if we want it, we can do that, but then it gets a little bit more complicated, because then we need to know which ones are the lifecycle layers and which ones are the base layers, right? Similar to what we do for rebase, we need to identify the layers. So we could do that, but then that means that we have to figure out a mechanism to do that, right? Most likely a label.
I would love a label, as opposed to having to ship two separate lifecycle images.
Could
One based on Scratch and one based on distro static.
I see what you're saying.
Like,
Okay.
not very valuable.
So
I would love to talk about the end user here, right? The person who's doing this, right? I'm only asking to be sympathetic to how I think a normal person is going to build a lifecycle image with, not from scratch, right? Just they're going to need some instruction or some documentation or whatever to say, okay, the lifecycle image has to look like this to be used in this workflow, right? Or we have to run make package or something, right? That's the only reason I asked the question.
Can we have Pack create lifecycle?
it sounds like that we're gonna need some tooling around this now. So definitely things to think about, but I want to be cognizant to the time which Terrence threw out there.
Yeah, do we want to, I guess, come back to this async on what we want the image to look like, at least on the issue. I'm happy to punt on the other spec thing because I don't want this whole meeting to be about the first topic. Should we move on towards kind of 15 minutes for the next two RFCs?
Yeah, I could sync up with Natalie and Anthony and make sure that we come up with something that we could at least bring up next time.
Cool. RFC 182, I think, is also you, Javier, on, well, you didn't write the RFC, but it's the project descriptor converter.
Yeah, so I was looking at it a little bit more in depth, and let me see what my notes say about this. Okay, so my comment, let me see if I could share this real quick. Blah. Okay, so I think my comment revolves around how we access this functionality. So my main concern is that certain platforms like Pack are going to need access to fields within this project descriptor. One case in point is the builder, right? Another one is, I think there's been talks about putting the image name as well. And so before, I would consider this pre-build, right? So before we execute the build, we need some information from the project descriptor. And so Pack, for instance, in this case, would use this quote unquote binary as a library, right? So we would have to be able to consume it as a library to do the transformation, to then be able to read from it in just one format. The one downside, and I think it's very similar to the rebase, is that there's a sort of expectation that because it's part of the life cycle, so like if you were to say Pack build, right, dash lifecycle image, you would expect potentially that it would be using the logic inside of there to also do the project descriptor conversion, because it's all part of the life cycle according to this, RFC. It's a component that's a part of the life cycle or shipped with the life cycle. But in reality, because we're going to be using it as a library, we wouldn't actually be doing that at all, right? We'd be using the most likely an older version of the converter in that particular case. And I think that could be a sort of like negative experience where we're not applying the logic in theory the way that it should be expected. I don't know if there's any real concern about that. Sorry, go ahead.
Is the concern the discrepancy between the version of lifecycle that is specified for one and then the version of lifecycle that's used as the library? Is that what you're concerned about?
Yes.
Yeah. I think in theory, like if the API spec for the descriptor, version or whatever, the schema version for the descriptor is really what should determine differences in behavior, and the version of the life cycle. Well, I mean, I guess I was gonna say it's a bug if they're different, but there inevitably will be. And so there could be, I mean, to your point, there still could be differences even if we don't intend them to be.
Yeah. So, I mean, I think we could chuck it up as a minor, inconvenience or concern. I think I had another comment in that regard.
I think we could just, I feel like this is sort of like, I could be wrong, but I don't think, it doesn't seem like people would care. I don't know, like, as an end user, I really care which version of the lifecycle is being used to translate my project toml from one schema to the other. That seems like something that somebody developing on the lifecycle or developing on Pack would care about. But I think the average end user is really not going to care. So rather than like struggle to make this, seamless, we could just output a warning.
So I think my concern is coming through like complexity, right? Where I know we had this discussion in some other maybe scenario or case, but it's starting to become really complex to determine where things are coming from, right? So like we had an issue about CA certs, right? That came up. And it's like, okay, the CA certs are being handled by Pacato and they're doing all this work, but the CA certs don't work in the analyzer phase because they haven't been injected at that point, right? So like you're trying to like decipher, okay, what's going on through this sort of facade of, of a system. And I think in this similar vein, right, for rebase, it's like, oh, we're actually not using the lifecycle image, even though you provided a lifecycle image, we're actually using something built into PAC, right? And so then you ask, okay, is it PAC that's doing it? Is it the lifecycle? And from even a maintainer's perspective, to keep everything in line, it becomes very hard. My ultimate goal, right, going back to this kind of notion of being spec and providing just simply tooling, is not so much about the user and whether they care or not. It's about, if I'm trying to work within this ecosystem and provide a life cycle, right, then I expect that I can replace the life cycle in my entire process within the use of PAC, right? So PAC shouldn't have this like preconceived notion of a very specific life cycle that I'm using, which is the one that the CNB project maintains. I feel like I should be able to replace all of life cycles notion with the one that I'm building internally. Right. So again, kind of modular pieces that all we're doing is figuring out how to piece them together. And this is one of the points where I feel like we're kind of going against that, because we're really much embedding them for the sake of a better user experience. So I get that, right? But at the end of the day, I think it's also detrimental to the maybe end goal of having modular components that people could piece together and work into their own products.
So, but then, so the only way around that then is well, 2 points. One, I don't want to take us like down a wrong path, but I think it's worth noting that confusion already sort of exists today, in that if I do PAC build -- lifecycle image, that lifecycle image is only used for the 3 phases, right? It doesn't replace the life cycle that's used for detect and build, right? And that could, I mean, we know that, but the average user might, especially if we're doing this thing where, you can create a builder and provide a life cycle image, it just creates more potential for confusion, right?
Mm-hmm.
So, but I'm just pointing that out as like a separate problem that maybe we don't need to discuss immediately. But the other thing that you mentioned was, okay, I want to just replace the life cycle for everything, right? And if we're doing this project descriptor parser, the only way to do that is to introduce a new phase, or to call it as part of like, right? You have to have a new, like PAC will spin up a container just to run this one thing. And that's a poor user experience because it'll be slow, but that's the only way that I can see that we can solve it.
Yeah, and I mean, I feel like we've contemplated that for rebase as well, for the same reason, right? It's like there's no way for you to replace the rebase functionality within PAC right now. And so this has come up. Obviously, we haven't taken action item or action on it. But I think, again, it's just, I'm not saying that we should solve it, but it's kind of, again, putting that out there, that we're not very decomposed as maybe we'd want to be. Let's see. The other thing that I think is pretty important here, and I don't think the RSC really goes into too much detail about maybe some of the handling of this, but it has to do with the platform API, right? So in this particular case, we're now associating the project descriptor to a platform API. Are we? I guess my biggest question is about the optionality of the project descriptor, right? From a spec perspective. So are we saying on the spec that now in order to be compliant, this thing needs to exist on a lifecycle? So like, let's think about lifecycle distribution again, right? Now for every lifecycle distribution, do we have to have this converter in there? So is that an open question in the RFC?
I don't have a super strong opinion, but I did have a more basic question about this whole thing, which is, if you look there, somewhere there, if you search for question mark, right? I was trying to do the mapping from O1 to O, yeah, does this make sense, right? The O2 project TOML has a concept of an inline build pack, right? The O1 project TOML did not. So, I just threw that inline build pack in the O1, the translated, O1, but like really, if my platform, so say my platform supports the O1 schema, and I'm an app developer, I provide the O2 schema, and I'm using an inline build pack. Sure, I could translate the schema over to O1, but my platform is still not going to know what to do with that inline build pack. So I guess, we error out in that case. Like I'm pointing out that this translator, it can solve some of the problems, but there are still going to be people who are just out of luck because their platform doesn't support all the things that they want to use.
So new features or functionality of the next project descriptor schema.
Yes. Yes.
Become unsupportable because of the association with the platform API.
Yeah.
I mean, it requires a rev bump to platform API, right, to support it?
But
in this world,
in this world,
well, in this like you're putting project descriptor translated thing in platform API, right? Whatever we're calling this.
Yeah.
Like the platformification of the project descriptor, right, is becoming part of the platform API. So if there's the inline case, but potentially you add feature X, right? Like it is not part of that translation thing. So it would require a platform API bump to support it, right?
Yes. So then it might not be worth translating it over, is what maybe I'm hearing. Is that right?
Well, I mean, I think like to Natalie's comment, right? Like you translate it over, but if the platform doesn't support it, it doesn't support it, right? Like inline build pack, just even though it's in the thing, doesn't work, right?
I mean, I guess maybe I would question why even translate it over. Because I guess the way I would see this is getting really complicated. So for platform 06, right, which is, let's say that the top one. Well, it's not. This is which one's the final one, Natalie? The one that we would get. Is it based off of these?
Oh, they're both translated into the same format. So this is like, I started with O1 schema, this is what I end up with. And the other one is I started with O2 schema, this is what I end up with. So this is like the platform version of it, not the project descriptor API version of it.
Is that true? I thought the underscore was platform O2 schema.
Yeah, it's O2 schema.
I have to go back and look at it again.
Yeah, that's why I
I-
got a little confused on that one, and that's why I only looked at this for reference.
I guess just for time check thing, we have like 13 minutes left. I want to make sure Anthony gets a chance to talk about his RFC, which we promised him. It seems like the both of you and Mamie are the people interested in this. Are you both available during office hours to dive into this more?
We'll get in a room and beat each other up for this one. Sounds good.
Cool. Sorry. Just trying to move things along a little bit.
No, I appreciate it. What a boss move there. Let me share my screen. Can you see this?
Yep.
Okay. I did just want to introduce this RFC once again for anybody who hasn't seen it already. It's supposed to be basically in addition to the previous SBOM RFC that got accepted, right? But I guess this original RFC only sort of specified for the build pack interface, right? This is basically trying to say for what we know as stacks today, right? Or more just the run image, like, hey, put this label on it with the digest of, you know, an SBOM describing the packages installed on the container image. That's basically at a high level. I know some comments were just given like this morning, but I haven't got a chance to look at it, but I did want to field some questions.
I don't know if someone commented anything about the paths already, but I was wondering about the choice of /SBOM at the root, because if we're going to have the build pack SBOM live in layers, config, you know, SBOM, etc., it feels a little like when you construct the image at the end, you'll see a folder called SBOM at the root that only has part of the SBOM. And then if you dig into the layers directory, then you get the partial layer SBOMs. So is there a way we could move that SBOM for the stack either into like, if we're going with this, like they should be close to the artifact they describe, you know, maybe like CNB stack or something like that as a location, or we could, you know, move them close to the other SBOM, but that feels a little weird because I think layers is empty by default. It should be able to be a volume. And so I don't think we want to put it in layers, but maybe like CNB stack SBOM or something like that to kind of match the pattern of the other one.
Yeah, that's a good idea. The only thing I was concerned about was putting it basically in layer. You know, that was my first thought.
Yeah.
Putting it in here, but I know at least Pack sort of clobbers everything, at least at the beginning of the whole process. So I think it's kind of slightly dangerous for, you know, to put it in here for risk of
Totally
getting wiped out. But yeah, CNB SBOM or something makes sense.
I'm just thinking about what the final image looks like. And if it, like, I think in the context of it's a stack base image, and it has SBOM at the root, and that's the SBOM, that makes sense. But then when you build the image, if it's going to be at the same place, then I think it looks like it's saying it's the SBOM of the whole image, but the image is changed. And so maybe just like moving into that CNB directory would help. That's my only feedback. Do you cover rebasing in this one?
I did not cover rebasing.
I would just say that when you rebase, it uses the new one and not the old one. Because right now, I think our rebase operation just moves the new layers and doesn't change any of the labels. And so I think it's important to note that
makes sense.
Yeah.
But you know, just to be clear for myself, when we rebase and move the new SBOM, we would need to merge it again, right? With all the build pack one SBOMs from the previous RFC, right?
Does this one talk about merging?
Yes, it does talk about merging. If it's Cyclone DX, we'll merge it.
Where does the merged one end up?
That's a good question. Yeah, I don't think I thought that one ahead. I think I just said merge it, but we can decide right now.
Yeah, maybe the like io.buildpacks.stack.sbom is permanently the sbom of the stack, and then io buildpacks sbom could be the sbom of the whole thing of the final image once everything is merged together or something like that. Or we could descope merging. I think that'd be okay too.
Could someone educate me a little bit on what merging entails? Like the way I envision it, it's taking all these SBOMs and then just literally putting them together at a high level, right? But when people describe merging isn't supported, I get the sense that it's maybe slightly more complex, where there's deduplication involved or something like that.
Maybe I don't know if a goal of merging is to work across Cyclone DX versions, but whoever's been working with the upstream folks on the Cyclone DX project might have more context.
Sorry, I don't think anybody in this call has quite intimate knowledge of that. We've sort of left it in their hands because we wanted them to suss out any of these nuances that we probably don't know. So
Yeah.
I don't think it's super complicated. If anything, maybe they support merging like from Cyclone DX 1, 2 to 3, and then you'd have to change some field names. That could be a thing, but I think it is kind of just shove everything in a larger list to some extent.
Is there, I haven't looked at Cyclone DX, but does it have sort of the idea of categories, or essentially being able to say this is a, OS level sort of dependency versus an application level dependency, that sort of stuff?
I think it differentiates, it has different types, right? But I don't think it considers an OS level thing different from a application level thing. It just considers an Ubuntu package different from a node module or something like that. Because they have pearls in them that reference the. Here's an example for node modules that I look at sometimes. This is from like the tests of everything. They have like type library on the component. Then the Perl, from the Perl, you can kind of derive, is this an NPM package? Is this a, whatever it is.
Yeah, because I guess the question about rebasing, right, is maybe what comes into mind on how that would happen, especially if we only then have a merged version.
You can just run them. Sorry, go.
I just want to bring up a quick point because I think unless I missed it, there was sort of an oversight in the earlier RFC for build pack provided SBOMs. It says that the diff ID for the layer containing the merged bombs will be present in a label, but it doesn't say what that label actually is. So whatever naming convention that we come up with for, it should be like kind of done with that in mind, right? But that being said, like your point about if we just throw them all together and we only have one merged one, it's going to make rebasing impossible, right? So we need to keep, my suggestion is we keep everything separate layer for each.
Each build pack?
No. The one layer for the build pack provided SBOMs, one layer for the stack provided SBOMs, and then if and when the lifecycle does a merge, it does a third layer with all the merged stuff. And that way, when you rebase, you bring in the new layer for the stack and you replace the old layer with the merged stuff with new.
Or we could just have a special directory, right? In the with stack and build packs together, we could just have a special directory for the stack one and just sort of replace that. You know, I just really think it's elegant to have one layer for all the bombs, right? If we can.
So there's just like one layer that you keep replacing.
Yeah, that doesn't seem ideal to replace one layer all the time. Especially from the base image, like I would think that layer stays there. And you add in a different directory additional bombs.
Okay, well, there's the source SBOM, right? The stack author rights, which is fine, that stays one. But then there's the merged stuff after, right? So there's two layers, right? One that
yeah.
one that pre-exists, which we're not touching it, but then the ones that we make or merge.
But then you'd have to unmerge it when you have a new base image. You need to take out the stuff from the old base image and put in the stuff from the new base image. That's not possible if you have a single.
The way I interpret what Andy was saying, or what Anthony was saying, is leave all the build pack SBOMs in those layers directories where they are. Those never get deleted, right? And so you have all the SBOMs for every single layer, actually all separate permanently in the image, and then leave the stack one where it is, you know, by label, you know, with its label reference, leave all that the same, right? And then on rebase, you just make sure that you replace both the stack one and you take the new stack one and the build pack ones and combine them together and add another merged label underneath. And so now you do have two copies of the SBOM, one that's completely broken apart and one that's all joined together. I think, and you have three labels, right? One label that's build pack SBOM layer, one label at the final image, one layer that's the stack one, and one label that points to the merged one. Is that?
I really don't know why we need a separate label for just the merged one. You know, I think merged and build pack SBOMs should be together. That's just me.
Oh, I see. Keep the merged and build pack ones together, and
yeah,
then
just have a special. Am I in the minority here?
I think I worry a little bit about the content addressability. It's like and the ability to sign things in the future. Like we may want to be able to sign the original build pack SBOM, right? Like you may want to know that the original build pack SBOM hasn't changed after a rebase operation, and then you would lose the context in the original build pack SBOM because SBOM is it's like a kind of a trail of something you might want to keep a tight chain of custody for. I think it's safer if we do a kind of append only in that sense. But I don't know if I'm a little tempted to say, I don't know if we need to merge the SBOMs together and then write that into a final SBOM that lives in the image at all. I wonder if we could put the merging off until we talk about cosine integration, because that's when we would actually merge them and then put them in a separate image. And then your image wouldn't need two copies of the SBOM. It would just have, your app image would have the disparate copies of the SBOM. An analysis operation on the image could do the merging at analysis time, right? So pack inspect image could pull all the SBOMs and merge them together if you want. And later we can add cosine support, which then takes all those, merges them together and creates the thing. And so another option would be just don't worry about it. For this RFC, say, this is how the stack SBOM is specified, and then we can push that off in the future. Or you could turn this one into one that talks about the cosine integration and uses that. I'm not super opposed to having the merged one in the app image pre-merged either, but I maybe lean a little bit towards doing the merge operation at the same time we write it in cosine format. I don't know if you have thoughts.
So I think just to circle back, I think merging was definitely out of scope for this RFC in this conversation. I think what Natalie was mentioning is just deriving a sort of format for labels to be able to identify where these different SBOM, references are. And so if we're good with that, then I think we could kind of punt on the merging and final SBOM to later.
Do you want us to, at some point, I know we're at time, but I do want us to opine on the name of the labels, just because that's going to be a blocker for the SBOM work that's currently underway. we need to know what to call this label. So,
Well, I think we preemptively named it in the support Docker files RFC, right?
oh, sorry, I missed that. What was it again?
io.buildpacks.sbom. Although I just kind of threw that in there. It wasn't a, it could change if people don't like it. I wasn't strongly opinionated about it.
Is that a single reference to all the SBOMs in JSON format?
Just a stack SBOM.
Just a stack SBOM.
Oh, but then what's the build one called? Because that's the one we need to know now.
Yeah.
The build pack one or the merge one?
The build pack, the layer containing the build pack provided SBOMs.
That Anthony named that, right? What's that layer?
RFC named it, and you know it's at this specific place. Yeah, right.
Is that IO build packs SBOM now too, or
no? It's a metadata label in the lifecycle metadata label, right?
I think we need its own label, right?
I like io.buildpacks.sbom.
Why? It's already derivable, right? Like it's already there. The data is there. Why do we need a separate layer, a separate label?
Because of composition could override labels. I think that at least.
All right, we're at time.
Yeah,
sounds good.
We need a separate label for the stack one, but we don't necessarily need a separate label for the build pack one because it's already there. We could have one though. I don't have a strong opinion about it personally, but whatever. Sorry, I just had to think about where everything's coming from. All right, thanks everybody.